Morning, class. We'll go ahead and get started. I'm glad everyone got the message. Save your trip to the campus, and hope everybody had a good week off. But it's time to get back, and today we'll do lesson 19. This lesson, class, as you can see, using support and scripting tools. And this is a lesson that talks about writing scripts. A script is like writing a program. Somebody writes a script to make things run automatically. You know, you're not expected to know scripting. You know, for example, I know Python well, and but you know, I had to learn it. So here in this chapter, it's just so you know can just understand that scripting is available, and it can be used, you know, just to help out with the processes if they have to be automated. And if you don't know how to write a script, you can, you know, if the company has developers that know how to write scripts, they can write the script if they're instructed as to what it is in the script. Okay, so anyway, let's go ahead and see what they have to say about scripts. You're going to see different scripts, you know, depending on what scripting language you use. Anyone can be used to accomplish the same thing. It's just a matter of preference. What scripting language do you want to use? So here we'll start off by looking at the objectives. Use remote access technologies, implement backup and recovery, explain data handling best practices, and identify basics of scripting. So as you can see, we will also look at backup as well. So the remote desktop tool, let's see here, let me get this a little bit bigger. But the remote desktop tool here is talking about if you are going to do remote desktop connection, which allows you to get access to a computer that's in a different location, right? So you can be able to provide assistance or whatever the case may be, or in this case, a remote desktop connection to be able to connect, you know, from a remote location into the company's network. So let's see what they say about that. You have to you know, think about security, right? Because think about it, it's somebody that's coming in from the outside, coming into your network. So so you got to think about granting the access. So you got to make sure that the person that's trying to connect is an authorized person. You know, you want to prevent snooping. You want to prevent somebody just connecting from the outside and they don't belong on your network because they're not authorized. And then patching vulnerabilities. You know, we've talked about patching, right? Is fixing things that aren't working the way they're supposed to work. I go back to the example that we use, the automatic updates that happen at night. You know, they're doing patching, they're doing fixing of things that they discover that are not working the way they're supposed to work. So here we look at the RDP, the remote desktop protocol. Says it's an executable, a client application and session encryption, and a multi-platform RDP client. So, you know, whatever operating system you're using, RDP can be used, again, one more time, to connect to a network. Then, you know, of course, that you have been authorized. I know it can be used, you know, a very good example, employees that are working from home. So you can see here what the screen would look like. This is Windows, and you know, you specify the computer, you specify the user account that's going to be logging in remotely to the network. You can see here virtual network computing, VNC. Let's see what they say. It says Mac OS screen sharing, secure versus unsecured third-party implementations. So remote desktop connection is one way to connect remotely. So let's say you're working from home. That's one way to connect. But there's other tools. It's not the only one. Here we're looking at a Microsoft built-in product, already comes with Microsoft VNC is a third party, but it works well and it can be used as well on multi-platforms. So again, the purpose of it is to be able to, use for a desktop-based remote access. So normally the best example I can give you is as employees that are working from home, they have a desktop at home, and you set up the remote desktop on their computer at home, so they can be able to make a connection to the company network. That's the remote desktop. So RDP server and security settings. So normally when you do this connection from the remote location into the company's network, the company has already set up a server that will accept your connection, so you can be able to connect. Once you connect, then at that point you have access to the resources on the company's network. If whatever folders you can access when you're at work, you can also access from your home environment as well, because that connection was made with a remote desktop from your home to a server that's accepting these requests to connect. And once you connect, the server keeps you connected until you disconnect. So security considerations: accounts allowed to connect. So set up the account and give it the permission to be able to connect. For example, here, the remote desktop connection, we're seeing that, and enable remote desktop, and you say yes, on. Okay, so he also will give the network level authentication, so they can be authenticated at the network level. And then the RDP restricted admin mode and remote credential guard. So you can't set it up. Again, one more time, how is it when you're in your company connected, and what permissions you have, right? You have the technicians have more permissions and rights than the regular users, which the regular users are called the standard users, right? So you want to keep it at the same level. You don't want them doing other things they're not supposed to do. We know that the protocol to connect is over the internet is TCP, and the port number of every application has a port number related to it, okay, associated with it. Well, the port number that's associated with RDP or the remote desktop connection is port number 3389. So that means on your firewall, you would allow access from any application trying to come in from 3389. So in this case that we're talking about here would be RDP, or the remote desktop connection. Let's say that you have your server working fine, you have the workstations for the employees working fine, and the connections, everything's working fine. But if you forget to enable port 3389, they will still won't be able to connect. So just make sure that you do enable this port on the firewall. And then you do have the open source RDP servers. So the open source or other servers that are not necessarily Microsoft, because they don't have to be. Okay, you have other platforms to allow the connections to be accepted. Okay, so you do have other, and here they talk about the open source RDP server. So just the term open source means what? We talked about Linux, right, which open source. I know that there's one for VPN, and it's called OpenVPN. That's an example of open source, right? Allows you to make a secure connection using VPN, using open source. So again, an example of open source is something that's let's just say it's not Microsoft, and because it's open source, might be made available free of charge. So the Microsoft Remote Assistant. So let me back up here a little bit, and let's look at this one, remote desktop connection. So the remote desktop connection, again, just to put it in perspective for you, is you are away from the company's, from the building, where you work. So you're remote. So that could be you're at home or you're traveling. So you set up the remote desktop connection so you can remotely connect into your company's network, and it's the same as you were at the company. You can open up your folders, your files, everything. Now let's look at this other one, the RDP right here, the Microsoft Remote Assistance, okay? This is again along the lines of just reconnecting remotely, but this is for a different reason, for a different purpose. Let's see here. Allow users to send an invite to connect over RDP protected by password, chat and request control features, and quick assist feature better suited to connections over the internet. And again, here we can see the remote assistance. It really, class, let me tell you what it is. Unlike the other one where you would connect to be able to do your work from home or from a remote site, this one is when the user is having problems and he needs assistance. But let's say that you're in Houston and the user is in San Antonio. Well, they're not in your building. You can't walk over there and look at their problem. Well, the remote assistance can be set up that when the user requires assistance, they can click on the setup that you made. There's an icon, they click on it, and then several ways. When I used to set it up, when they click on it, it sends an email to the tech that's supposed to assist them. Normally, they will all already have communicated with someone that's going to provide help to them. And then that person that's going to provide help to them could ask the user, send me a remote assistance invitation. So when they click on the icon, the person needing the help, it sends the invitation. The way I would set it up is through email. So then the technician receives the email. It's a special email, which is for assistance. They open up the email and it has a link. And on that link, the technician clicks on it, and that link connects them directly to the computer of the user that sent the request. And I would have it set up that once it connects to that user, that it would ask the user the question, do you want to allow this person to connect or not? The reason I would do that, and that's a nice feature, because if a hacker was able to try to connect remotely for remote assistance to your computer and you didn't send that request for assistance, they might just get into your system straight through. So so by setting up that allows the user that needs the assistance to select yes, allow the user, or not allow the user, this way you cut out any hacker trying to get into your system, because you have to accept the connection or not. And because in a situation where the user is needing help, they're expecting you to connect, so they already know. So they see who it is that's trying to connect. They know you're the technician. Then they would say yes, allow this user to connect. And then once you connect, you take control of their computer. It's like you're there at their desk, and you take control of the keyboard, you take control of the mouse, and you do whatever it is that needs to be done. Well, that's one method. The other method is that you instruct the user where to go and where to click, whatever you prefer. Sometimes you have to take the control because the user doesn't know enough about where to go, and it's easier for you to just go straight to research where the problem may be, and then you can fix it. Other times, like I worked at a company where we provided this type of assistance to the users, but they were external customers. They weren't employees of the company. They were our customers. So our company would not allow us to take control of their computer. It would just allow us to look at their computer, but they would have to move the mouse and the keyboard and accept the options that you would instruct them to do. So two ways. But if they're internal customers, like employees of the company, and it's a complicated problem, you can't take full control. That's the difference. Remote assistance. This is for you to connect to the user to fix their problems, and you take control of their computer. The other one was RDP, remote desktop connection, was to allow the users to connect to the company network so they can do their work. But anyway, two types of remote connections here. I'm telling you, this remote assistance, I relied on it. I like it. It just helps the technician so much, especially now where there's so many remote networks connected to the company's computer. I'm sorry, to the company's network, that you have to support the users remotely, and there's no better way than this. I relied on it, like I said, and it just like being there, it helped me a lot. And of course, I was able to fix that problem for the user quicker, and the users loved it for that reason as well. So these are tools that you sooner or later are going to find that you're going to be using. And again, if you're providing the support, this is one you'll be using. And again, whether it's the Microsoft product, the remote assistance with a Microsoft product, or whether it's a third-party tool, it doesn't matter. It's just the fact that you can connect remotely and take control of the computer. Okay, Secure Shell. Secure Shell is a way to connect to equipment remotely as well. There's another command called Telnet. Right now, we're talking about Secure Shell. That's the same thing as Secure Shell, but the Telnet is not secure. It sends information in clear text, right? So if somebody is spying on you, and they're looking at the packets of data going through the network, they would be able to read them, the data in there, but not with Secure Shell. So going forward, use Secure Shell and not Telnet, unless you're doing Telnet inside the company building to other employees. But if you're going outside over the internet, Secure Shell. So here's a remote terminal access to command line shell, the Secure Shell server. So to be able to do this, here the company might already set up a server to be able to accept the connections. And again, this application of Secure Shell, the port number for this one is port number 22. So you would open up port 22 or enable port 22 on your firewall. Remember the port for remote desktop, what was it? For remote desktop, the port number is 3389. Well, for Secure Shell, it's port 22. And then you have the Secure Shell client, password authentication, and then you have a public key authentication as well. So these is just to be authenticated. So if you don't have the public key authentication, and the server is expecting a key for authentication, you don't have it, you won't be able to connect. One more time, to stop hackers from trying to break into your system, because a hacker will not have the key. Again, one example for Secure Shell is let's say that a company requires support for their routers, okay, that are in the company. Well, and let's say that the company doesn't have a technician that works on routers. Well, if you hire, let's say, a third party, a consulting firm to give you that support to help you with routers when you have problems, you can set it up so they can come in with Secure Shell, and then you give them the address of the equipment and of the Secure Shell server, which normally would be an IP address. So that all they have to do is type in SSH and then the IP address. Here, I'll just put it on the chat what you would type in. At the command prompt, you would type in SSH is the command. Well, the command prompt looks like this, right, class, as you know, like that. And you would type in SSH, and I'm just going to make up a number. If you knew the address of the equipment, you would type in 192.168. Let's say 1.50, for example. That's what you would type in, like that, and it would go over the internet and connect to that equipment in your company. And then, of course, the equipment then would ask for a user ID and a password that you would type in, and then you would have access to the router to be able to make your changes. Again, one more time, you connect directly to the equipment. It's the same as you being in the building, walking over to where the equipment is, connecting for example, your laptop with a cable to the equipment, and then you open up the configuration to make any changes. This is the same thing. It's like walking over to the equipment and then connecting to it and putting in the user ID password to get in, and you can make your changes. But the difference here is that you're far away. You could be in Houston, the equipment could be in California, but it's like you being there. It's a great tool. I work for a company that we needed support with the Cisco routers, and anytime we had some problems, we would call the company that gave us the support. They would secure shell in, and then they would make whatever changes needed to be made. Again, another tool to help you do work remotely. So the desktop management and remote monitoring tools. Here we see here visibility, says remote monitoring and management. Says desktop management and unified endpoint management. So again, this is just some application software to help you manage certain equipment remotely. Okay. And again, one's called the remote monitoring and management, and you can monitor certain equipment that's very important to your company. And but you're not at that site. You're in Houston. This equipment is in Dallas, but you still need to monitor it. There's applications to help you with that. So the RMM and the UEM. And then you have a common features. Says perform monitoring and log collection, so you can monitor and any exceptions, any errors, go to this log, and you can always look at the log. Remember, an example of a log could be what? Event viewer. Event viewer has what? System logs. It has application logs, if you remember. And then you can do security scanning. You can push a deployment. Okay, if you needed to install an application on equipment that's remotely, you don't have to drive over there or fly to that remote location. You can push out the program and to get it installed remotely from where you are. So if you're in Houston, you need to install something in Dallas, you can push it out from where you are. And then of course the remote support. We talked about remote support. Again, there's other products that allow remote support as well. So these are some of the advantages, again, of having this desktop management and remote monitoring tools. Then the last one there, the Intel vPro, AMD Pro hardware support for out-of-band remote access. So here, one important point here, class, is the out-of-band. If you don't know what the out-of-band is where if you're connecting to your remote sites and you're going through your regular infrastructure, well, you're within the infrastructure of your company. Let's use the example. If somebody was spying on you and you're doing these things, they know what you're doing because you're doing it through the infrastructure of your network that they've hacked into. The out-of-band is another way of connecting to these other sites. Let's just say something as simple as you have a modem. And through the modem, you can dial from Houston to Dallas and connect to the Dallas network through the modem. Now you're bypassing the infrastructure of your company's network. So if somebody's spying on the company's network, they're not going to know that you made a connection because you did it through the out-of-band, outside of the company's network. You did it through a modem. Sometimes if you suspect some hacking and you need to notify users from the other networks, you may want to do it out of band, or you need to put a fix, and you don't want the hackers to know. You can do it out of band. This way, if they're spying on you, they don't know that you're doing something. So that's what they mean by out of band, to remotely connect outside of the company's normal processes. Other remote access tools, screen sharing software. The screen sharing earlier, we looked at, and let me just back up here. Hold on, remote desktop tools. Okay, this is to connect remotely from your home, for example, to your company, and then you have the remote assistance. Okay, remote assistance could be considered screen sharing software, because on the remote assistance, the user can give you the access to share the screen so you can look at the screen. So third-party remote desktop tools designed to work over the internet. So VNC was a third party, but there's others, class, to be able to take control. So it's not just those tools that are built into Windows. The VNC is a third party, and there's other products as well. There's one called Go to My PC, and there's others, but again, just to give you an idea. Video conferencing software. Most include a basic screen share client. Well, guess what, class? Video conferencing software is what we're doing right now. Okay, so what product is that? WebEx, right? But there's others. That's not the only one. It's Zoom. I don't know if anyone here uses Zoom, but again, there's others as well. And then you have the file transfer software, and this is, for example, FTP. So there, but again, you can see easy sharing via Bluetooth. Again, I know there's you know, with the mobile devices, you have the AirDrop and things like that that allow you to you know, to do like accessing files and sending files over the network wirelessly. In this case, with the AirDrop to another computer. So Apple AirDrop, Windows Nearby Sharing, and the Android Nearby Share. So again, file transfer. So it's like very convenient to transfer the files if you don't want to do it through the regular procedure of just having a shared folder and being wired. Okay, and then you have the virtual private network, VPN. So the virtual private network, again, lends itself very well with RDP that we saw earlier, RDP to allow users to connect from home to the network at their company. You could set up a VPN, which is the link that connects a user from remotely from their home, for example, to the company's network. So that establishes the link, the actual connection. Then, of course, you click on the icon, it connects you to the server, and then you have to put your user ID and your password, of course. Connect your remote host to the local network over that secure tunnel. So VPN creates that link. The nice thing about VPN, it's secure. Anything going through that link is encrypted. You don't have to do anything just by the simple fact that the connection that you established was with VPN automatically encrypts, and then it can be more secure than opening or port forwarding a remote, a desktop, and secure shell. So again, more secure. VPN is more secure because the other one, port forwarding, just means that you're just making a connection, but it's not encrypted all the way through from point A to point B. Only your user ID and your password could be encrypted. But what about the traffic that's going through there? But nonetheless, these are tools that'll help you connect remotely. So class, what did we look here in topic A at remote desktop tools, the RDP server and security settings, right? That the most desktop protocol to connect remotely, the Microsoft Remote Assistance for you, the technician, to connect to a computer of a user having a problem, so you can take control of the computer and fix their problem. The secure shell is another way to connect to equipment directly, let's say to a server or to a router. Either way, a server or a router, doesn't matter. And then the desktop management and remote monitoring tools that allow you to monitor remote networks. You know, just to be proactive in case something doesn't look right, and it can generate logs that you can look at them remotely. And then you have other remote access tools. So there are other tools, again, that do the same thing. And then it's a matter of what the company decides they would want to acquire to do their remote, you know, activities. All right, class. Now we go. Now they're going to talk about backup. You know, we've talked about backup throughout the duration of all the modules of this course. And we know the importance of it. You know, we said, you know, before you work on a user's machine, back up the data, that kind of thing. So here, they're just reiterating some of the things that we talked about. The nice thing about Windows operating system, it comes with a backup program, but you can buy third-party, more robust enterprise level to back up the data files from the server to whatever media, whether it's tape or another, you know, hard drive elsewhere or the cloud. But anyway, criticality of data backup and recovery operations. What to back up, right? You don't want to back up every single thing what is the important things that you have to back up? So you have to determine that. Normally, class, rule of thumb is you want to back up the data files that's used to do the processing of the company's business, okay? And then how to store backups as well. So in a minute, they'll tell us how to store backups. So do you want to store backups in the same building at the company? If you remember, we talked about backups, or do you want to store the backups in a different building from your company, right? That's called offline storage. Reason for that is we know, what if the building catches on fire and your backups are in the building, your backups also burn, right? But if you put them in a different building and the building burns, well, your backups are safe in a different building. And then testing and validating recovery procedures. So if you have a disaster on a server, you lose the data, what can you do? Well, you rebuild the server, right? And once you rebuild the server, you need the data. What do? You take the data from the tapes and copy them back to your server, right? And that's recovery operations, restoring the data from the tape. But once in a while, class, once in a while, it's a good idea to have a test machine and get a tape, a random tape of your backups that you have, and try to restore it on that test machine. Because sometimes tapes can go bad and you think you have a good backup, and when you try to restore it, the tape has gone bad and you can't get the data back. So periodically check that your tapes are good, that they have not worn out so bad that you cannot get the data from the tape again. So testing and validating recovery procedures. So, a good idea to periodically do that. And then Windows tools for personal data backups. Windows can back up your file history. Windows Backup and Restore Center. So this is the tool that Windows gives you. As I said, you don't have to go buy a program to do your backups. Windows gives you that. It gives you the application, the backup application that you can just do your backups. You go to the process, and then as you can see here, you have you run the backup that Windows has in the settings, and you can tell it if you already have the tape on the tape drive, you can say backup now, and then back up my files every hour, or you could say every day, or every week, and then keep my backups until space is needed. If you're backing up to a different location, and let's say the different location can take 5 days worth of backups, so you say, okay, keep backing up until it fills up, and then stop the backup so you can go put a new tape so it can continue the backup. So you have different options here. And then back up these folders, and then you're going to tell it what you want to back up. Remember, we said, what do you want to back up? So put the folders that contain the company's data files. And once you put that, then it'll start doing your backups. If you want to do your backups every night, you put it here daily. And then it would ask you on the daily option, what time? And you say, I want to do it at 10 at night, because you want to make sure everybody's gone home, nobody's using the files anymore. So again, backup operations. Again, you'll find you could be the person that's given the responsibility of doing the backups. And if your company has a third party, you use that. If they don't have a third party product, you have one built in. And as a matter of fact, you have backups on your computers. You have the backup. If you want to back up at your home or your small business, you can back up as well. And then you have the backup method that I covered that, where you have the full, the incremental, and the differential, if you recall. Backup change full with incremental or differential, and then synthetic backups that reduces transfer requirements by synthesizing next full backup for incremental jobs. So pretty much, class, here is what they're saying is in the full backup is you're going to back up all the data. You're going to back up all the data in the full. So let's say you do your backups every Friday, okay? and then come on Monday if you want to do the differential or the incremental. Let's see here. Either one, it's up to you. The differential will copy the data, for example, for Monday, and it will copy it, and you go into a tape, okay? And then on Tuesday, if let's say that's what you select, you're going to do Monday through Thursday, the differential, because remember, Friday you do the full, copies everything. But on Monday you do the differential. So on the differential only copies the information that changed on Monday's processing. So if only 10 files were modified and changed, it will only copy the 10 files. It will not copy all the data because that's already been done on Friday. And then on Tuesday, any files that changed on Tuesday, then that backup would back up all the files that were changed on Monday and all the files that were changed on Tuesday. So now you have 2 days of backup, the files from Monday and Tuesday. Then on Wednesday, some more files are modified and they change because they're updated, they're deleted, or whatever the case may be. So the Wednesday backup then would have the files that changed from Monday, the files that changed from Tuesday, and now the files that changed from Wednesday. As you can see, it's accumulating every day, the files that changed every day, okay? That's the differential. If you go with the option of incremental, then the same thing here. Every Friday you do the full backup, you copy everything. But then on Monday, your backup would be any files that changed on Monday. Let's say it's 10 files that changed. It will only copy 10 files. Then on Tuesday, any files that changed on Tuesday will be backed up, but it will not back up the files from Monday, only the ones for Tuesday, only the ones for that day. And then on Wednesday, we'll back up the files that changed on Wednesday. It will not back up anything from Tuesday or Wednesday. It's not accumulating the backup like the differential is. The differential keeps growing every day because it's taking the previous days, like Monday, Tuesday, Wednesday, Thursday. The incremental, it's only does the individual days. So whichever one you decide is best for your operation. The differential, the first on Monday, for example, differential might take the same amount of time as the incremental on Monday, whatever files changed. But on Tuesday, it has to take the time to back up Monday's data and Tuesday's data. The incremental only needs the time of Tuesday's data because it's not going to do Monday. So then incremental is faster. And then on Wednesday, again, here it has to back up Monday, Tuesday, Wednesday. So it's going to take even longer. Here is fast. It only backs up Wednesday because it's only does 1 day. So if you don't have that much time for backup, you might want to go incremental because it's going to be faster than differential. But if you have plenty of time, differential it will work for you as well. So those are the 3 options, class, for backups. And when we covered backups earlier in this class, I wrote down the diagrams of how each one works. But here they tell you exactly how it works. And when you're doing your backup here, when you're selecting the backup options, here, for example, let me see here. Right here, when you're selecting your backup options, there's going to be one option that's going to say, do you want to do a full, or the option would be, do you want to do the incremental or the differential? So here in one of the options, you would select that. So the backup media requirements: grandfather, son, media rotation. Label tapes for monthly, weekly, and daily backup jobs. So you rotate these tapes. Let's say if it's only on Wednesday, I'm sorry, weekly. If it's only weekly, you back up. Let's say Friday you do a full, and then you do month. The next week is Monday, Tuesday, Wednesday, and Thursday, right? And then you have to do full again. So then you might want to use the tape you used the week before to be the full, because nothing happened, you don't need it anymore, and you just recycle those tapes, you know, over the week. So, but if you say no, I want to save at least 2 or 3 weeks before I reuse the tapes, so you can have 3 weeks backup. Then of course, then you got to label each one so you'll know, and then you don't reuse the same tape. For example, today you do a backup 11/28, and you say I want to keep 3 weeks backup, then you'll have to have at least 3 weeks worth of tapes. So in other words, you have to have 5, 10, 15 tapes, because you don't want to reuse them on a weekly basis. You want to use them, reuse them every 3 weeks. So again, whatever you decide you're going to do. And then you do 1 week, you save it. You do a second week, you save it. You do a third week, you save it. And when you get to the fourth week, you get the tapes from the 3 weeks ago, and you recycle through those, and then through the other ones again. So it's just a matter of rotating the tapes, however long you want to keep them. And then you have the on-site versus off-site. I remember I said, do you want to save the tapes in the same building as where your servers are, or do you want to send it off-site? Remember I said, if there's a fire, at least they're not in the same building where they'll burn. And then you have the online versus offline. This is the other one, right? The online, if you have online backups, there are services out there that allow you to do that. So you subscribe to the service, and your backup then is going off of over the internet to the offline site, whoever you're paying to do that. I don't know if they're still in business. Carbonite is one service that does that. There's others, or you could be sending it out to the cloud. That's the online backup. So there you're not using your own tapes. This is done by the online company that's giving you the service for backups. The offline is the ones that you do, on the premises. And then you have a 3-2-1 backup rule. So you might want the 3-2-1. This is the cycling of the tapes that we talked about. Just a little bit of what they say about some of these things is for example, a little bit about the grandfather thing. The scheme presented here makes use of the incremental backups on these tapes, and then you're going to recycle. As I said, you might want to know that the 21 tape schema is widely quoted. The 21 tapes means you have 21 tapes, and you use a new one every day, and then once 21 days go by, you start again, right? Like I said, 3 weeks is my example, but here they're saying 21 tapes. That could be covered 4 weeks. And then, of course, you do your full backups like on a Friday, and then, of course, you do the incremental or the differential, whatever you decide you're going to do. But again, you come up with your own strategy. All the strategies work. It's just a matter of which one you prefer to use. So backup testing and recovery, as we said, sometimes tapes could go bad. And you want to test it, see if you can bring the data back from the tape. So tape the restore to an alternate location. Don't restore to your regular servers, because those are the servers that are being used for production. If you restore to the production servers, you're gonna destroy the current data and put data that was from a week ago, for example. You don't want to do that. So have a test server to restore your data to see that it can bring it back from the tape. And then, so this is for verification. There's something called data validation via hashing and media integrity. So again, in your restore, it can do that for you and check this hashing, which is something that's computed while it's restoring, and the results should be the same as when you backed it up. It makes the comparison. It says, okay, the tape is identical. When I restored it on the server, it's identical to what's on the tape. The hashing will confirm that. And then you have the check configuration. It says, are all necessary locations and files included? So once you restore, make sure that all the files were copied back to this test server, and they were put in the right location, in the right drive, in the right folder, okay, and so on. And then a frequency of testing, it's up to you. You want to test every 3 weeks, you want to test every month, every 2 weeks, whatever, it's up to you. But it is important to do that to make sure that your backup media is not failing on you, because stop and think about it. If you do a backup, we're going to assume that it worked, right? Everything went well. But what if the tape was worn out so bad that it wasn't taking the backup? But you don't want to find out that it didn't work when you have to restore from a disaster. That's why by doing the testing frequently, you always know that you have good backups. But again, backup is important. Everywhere you work, you will have backups. Whether you do them or somebody else does them, there will be backup procedures. So here we looked at what, class? We looked at backup operations. We looked at backup methods, backup media requirements, and backup testing and recovery best practices. All right, let's look at topic C now. Let me see how many. Okay, topic C here, they have a regulated data classification. Here is talk about data types. So this is the PII, the personally identifiable information. I believe in the last lecture, I talked about that. Remember, this is confidential information where you don't want other people that are not authorized to look at the data to look at it, right? Because they can put pieces of information together to find out who the person is, right? As I said, they can see this is the address and they attend Houston Community College. Oh, I know who this person is, that kind of thing. So personal government issued information. Again, if you work for a government entity, government has a lot of information that's confidential. Health data, you have something called HIPAA. Is one where the data is supposed to be very confidential because it is just the symptoms diagnosis of patient care, that it's only personal to the patient, and now the people that need to know about it are only the caretakers, the doctors, etc. And then credit card transactions, the same thing. Like you don't want anybody seeing, first of all, what you're buying, your transactions that you're purchasing. So again, this is data that's regulated. I know the credit card transactions are regulated by an entity called the PC, which is the credit card organization that controls the procedures for that. Again, we have looked at this already, but again, this is known as regulated data that you have to take special care that it doesn't get in the wrong hands. And then, okay, and what is the special care is, again, doing the data handling best practices. Okay, where you want to make sure that you don't leave documents on top of your desk that have confidential information, for example, or your computer unattended, that somebody can sit on your computer when you go to lunch and look at what you have. And then, of course, data retention requirements. Some data has to be held for at least 7 years, depending on what data it is. I know, like income tax documents, for example, they have to be held for 7 years. There's other data that there's requirements, and you have to find a place to store this data, to meet the regulations. So prohibited content and licensing issues. Again, prohibited content, that goes without saying. Like a DRM, which has to do with recordings and music and things like that. People should respect the rights of these owners of this of this content. But anyway, here, for example, the prohibited content, the software licensing, the end user license agreement, right? License compliance monitoring, valid licenses, expired licenses, open source licenses. So a lot of people say, oh, if I get a copy of Windows 11 from my friend, I don't have to go buy it, right? Well, this is not a good thing, right? That prohibited content, it's only supposed to be used by the one user only. And again, so it has to do with the end user license agreements. So somebody that has that license, they agree that this is for my use only, and nobody else gets CD to go install Windows on their computer. And I have the product key that came with it. So when I install it on my computer, I put the product key, right? And then, like I said, you have the hackers or the people who want to pirate it, you give them your CD, they install it on their computer, and they find a fake product key. So now they didn't have to pay for the product, right? So those are things you don't want to be involved with. And the digital rights management, which has to do with content that people, just for example, in the music industry, you don't want to bootleg the music because people, the artists, they write this music, they sell the music. That's how they make their living from the sales, and they get some revenue from that. Well, if people start pirating all their content of what they created, then they'll have no revenue coming in. So there's the digital rights management as well. So us being in the IT industry, we have to be honest. We have to respect all these rights and all these rules. So again, respect the end user license agreements and respect the DRM. Okay, we go into incident response, security incident types. This is computer security incident response team, the CSIRT. This is when there's a breach on the network. Somebody hacks into your network, breaks in. There has to be a team to be able to fight back that attack. Okay, or if it's a natural disaster, if it's a flood and some of the equipment is not available anymore, it's a disaster. So there has to be a team to be able to fight that incident and get things working back to normal. Okay, that's what they mean by the incident response. So you have your first responders. Somebody's on the team that are first responders, and those are the people that get called in first. For example, they say there was a flood and these servers got flooded. So the first responders had to take some action and whatever it is that they have to do, go buy a new server, get the backups to bring the data back, whatever the case may be to recover. And then inform management and law enforcement. If it is a break-in, an attack, and they got into your data files, that's a different type of incident. And if you want to, you got to recover from that. You got to kick out the attackers, and you got to recover whatever it is that they broke or corrupted your data. But you also want to prosecute if you can catch them. You also have to notify law enforcement. So data integrity and preservation, right? So if somebody breaks in, they could go in there and mess your data up, right? So you want to make sure your data is always correct. So this is the nature of digital forensic evidence. So this is the area of information technology that deals with looking at files after there's a break-in, an incident from an attacker, to make sure that they didn't corrupt your files, your data. You can look at tracks that are left on your hard drive to see what they tampered with. Again, you have to be highly technical and knowledgeable in how to do these steps. Okay, so this would be more for a higher level tech that's taken, for example, some higher level security courses. But anyway, it's good for you to know that these things do occur in a network. Documentation of incident and recovery of data, right? So I have documentation of incident and recovery of data. So identify the scope, the record scene, and isolate hosts and devices. So you gotta identify the scope. You gotta identify how much of the network did they damage or did they get into. Okay, and you gotta record that, and then you isolate the host and devices. So you say they got into 2 of the servers. We have 10 servers. They got into 2 servers. So now you know your scope. You don't know what they did. They could have planted some worms, which is like a virus that spreads, right? So that's why they say isolate those. Isolate them until you do the research into those. They call it the forensics to find any evidence. If you don't want to destroy the evidence, isolate them, because if you don't isolate them, Another process that the company does, a regular processing, could write over the evidence that was left by the attacker. So by isolating that, also is a reason is that they put a warning not to spread, but the other thing is not to destroy the evidence until you look at the evidence and you record the evidence. Because sometimes if they do catch the attackers, some companies want to prosecute and take them to court. They have to have the evidence. So here I use live forensic tools or video to extract data from systems that are still powered on. So there's special tools that help these forensic analysts discover the tracks that were left by the attackers. Use write blocking imaging tools to make copies of fixed and removable disks. So write blocking is a special way of pulling data off your disk to keep everything intact. Because if there's evidence, a regular copy could not copy the evidence, only the regular data. But here you want to copy every single thing. And then I use hashing to validate integrity of the images. So whatever hashing is on the hard drive that was attacked, when you pull that off, you want to look at the hash on when you pulled off to your backup that has the same result of the hash to tell it, okay, you also pulled the evidence. Everything's identical. And again, these are tools that are available to these people that are doing the forensic analysis. And then bag and tag physical devices. So if anything's going to be kept for evidence, put it in a secure bag, just like the police do, the investigators, and seal it so nobody can tamper with that. You never know, somebody within the company was the attacker, and they might want to come in and tamper with the evidence to destroy their tracks, to hide their tracks. So always securely seal it and make sure nobody goes in there and tampers with your evidence. Because stop and think about it. If your evidence is not good, because somebody messed with it, when you go to court wants evidence. If you don't have it, then you're not going to be able to do anything. You won't be able to prosecute the attackers. And you also have to make sure that the chain of custody is a good chain of custody. That once the investigators that do the forensics and they bag and tag, they're going to give that to somebody else. And then that other person is going to do something with it. And then once they're done, they give it to a third person and so on. That's a chain of custody. It has to be documented who puts their hands on this evidence. And the only people that put their hands on this evidence has to be only authorized people to handle this evidence. That's why you have to keep track of who is touching this evidence. And if somebody that's not authorized touches it, then something has to be done because they're not authorized. So keep track of who's handling the evidence. That's what they mean by the chain of custody. And then the data destruction method, we talked about this as well, right? Once you don't need, for example, a hard drive, you just don't give your computer, or you don't need the computer that has hard drives. You just don't give the computer to Goodwill, for example, because there's information on those hard drives, and it's confidential. So you got to do something, right? So that data doesn't go with the computer. So here they say remnant removal for repurposing and recycling. So if you're going to reuse those drives, make sure you remove everything. And we talked about erasing, if you remember, standard formatting. So you do the formatting, risk of recoverable data remnant. So just the standard formatting deletes your files, but there's some tools that can go and read that disk, and it doesn't read it based on file names. It reads it based on the zeros and ones, and it can still pull data off. So there could be some data remnants out there. So the best way is just to erase and doing the wiping, hard drive versus solid state disks. Make sure you have some tools that can completely wipe out everything, the remnants of data and all the data. One method is a low level of formatting. And low-level formatting is a special application. This is used by the manufacturing companies that manufacture your disk drives. They do a low-level formatting. So when we get them, we the techs all we do is a high level format. But if we get the software to do low level, we can also completely wipe them out. And then you have what they call instant secure erase, the crypto erase. So again, different tools here. The erasing, wiping. There's one term, if you remember, called degaussing, which is a very heavy duty magnet, right? And so on. So just make sure that you're getting rid of the data. Some companies go as far as you remember as destroying the disk. They hit it with a hammer. Some have some machines that eat up the entire drive and break it up into pieces. Anyway, whatever method your company uses, make sure it's a safe method to completely wipe out the data that cannot be brought back, cannot be recovered. So disposal and recycling outsourcing concepts here. As a specialist at destruction machinery, remember I said the shredding. It takes, even though the disk drive is metal, it can still shred it, break it up into small metal pieces. Or incinerating, they burn it up, they putting it in the fire, and degaussing, the heavy duty magnet that I mentioned. And then the outsourcing concepts, a third-party vendor, certification of destruction and recycling. So if somebody's going to destroy your data, of course, just make sure that they're certified and they can do a good job of doing these things. And then do-it-yourself destruction methods is drilling and hammering. If you're going to be the one, you're not going to pay a third party. You can take a drill and drill into the hard drive. It makes it unusable. Or some companies take a ball peen hammer, the hammer that has a little ball on the other on one end, and they bang that drive. Once they bang that drive really hard, messes up the read-write head, the platters, and all that, so that drive doesn't work anymore. One more time, that is making sure that you're destroying the data on those drives. So here, what did we look at here? We looked at regulated data classification. We looked at prohibited content and licensing issues. We looked at incident response, data integrity and preservation, data destruction methods, disposal and recycling and outsourcing concepts. So here again, these are things that you as an IT tech are going to be involved with to some degree. Okay, and now you know the importance of making sure that the data, it doesn't get in the wrong hands. All right, class. Last topic for the day is identify basics of scripting, which I talked a little bit about it at the beginning. And this is just, a computer program in essence that will do something. You automate it, okay? So let's look at that. Here we looked at shell scripts. Let's see what they say about that. Development environments, okay? Say shell scripting language, general purpose scripting languages, programming languages, additions and integrated development environments. And then you have the Linux shell scripts, and then is the shebang, and you have execute permissions. And again, in the shell scripting, it's just what application are you using? So they have their own individual shells. So here, they're showing you some Linux here. Okay, you would have to know Linux, and they're creating a program, and they're putting content in this program here. Hello world is something that's going to be put in there, and then that's all they put here in this shell, and they gave it some permissions, read, write, execute, and so on. A very, very, very elementary display of a shell, but we're going to look at more detailed here. So let's look at this one here. The basic scripting constructs, for example, comments. You can put comments here if you're going to be doing this shell script for in Linux. If you're going to put a comment in your instructions, because remember it's a little program, the comment is a pound sign. The pound sign doesn't do anything. It's not an instruction that runs. All it is just information to let you know, certain information about the program. Like here is demonstrative syntax in Bash. And then you would have to know, class, you would have to take some training and learn how to write the scripts, how to write the programming language. You have to know the syntax. So it's not something right now that you could do. I'll tell you that if you don't know how to do this, the scripting. And so the reason I tell you that is because if you see this, it's only FYI to know that these things can be done. And you can do them eventually once you go learn the language, and you can write these scripts. And it ends up being a file that's executed, and it runs all the commands that are inside. So if I would run this file, whatever name they gave it, it would run these commands. So here, as you can see, it's doing some comparisons. If minus a z happens to be a 1, then this, a print on the monitor, hello world. If it's not $1, then, as you can see here, else, if it's not this, then do hello world S1. And that's it. End of the if. That's it. In. And that's a little program that all it does will do this. No more. Nothing more. That's simple. Very simple program. Okay, very simple script. So it just it uses loops and uses if then else a Boolean logic, and you have operators. Operators is like you can add, you can subtract. Here we don't see that, but again, if as you can see, and it has a loop. If it equals this, do this, else do that. Well, actually, there's not a loop here. Right there, it ended. It was just one command. But there's some commands that you may be adding something, and until it equals 10, continue or going back to the beginning and cycling 10 times. That would be called a loop. It keeps going round and round. Okay. So anyway, once you write, you do this, you save it, whatever name you give it. When you get ready to run it, then you would run the program by typing in the name of the program. Windows has their shell. Okay, here we look at the Linux shell. Windows has their shell. It's called PowerShell. Again, you understand the concept of the script to do something. Here in Windows, their PowerShell allows you to write the program. Here, as you can see, you have some commands. If test path, something or other, remove something from the drive, and so on. So it's not just a very basic little program here. And then, you save it, and then when you want to run the program, you run the name of that program. Let me, for example, give you just a very simple example of one. For example, another way is a Visual Basic Script. This is a programming language, and it does the same thing. It allows you to write the commands. I used to do VBS quite a bit, which is a full-fledged programming language. You can write it to do your scripts, to automate processes, but you can also write it to do other features, other functions in your company, to run full-fledged programs that compute things, payroll checks or whatever. And then you have another called a batch file. Okay, so let me give you a quick example of they all. The focus of them is the same for all. Okay, it's just which one do you know? Do you know PowerShell? Do you know the basic script here for Linux? Do you know Visual Basic? Do you know Batch? Okay, so which one you know is the one you use? So here, let me. Okay, class, 1 minute here. Let me just capture the role at the attendance.
1 second here, class.
So if you say, well, I know how to do the batch scripting. So really all it is, you open up Notepad. Notepad is just an editor, just like Word. Okay, but you do Notepad. And then let's say I wanted to put something, a comment. This is a sample script, okay? And then really all you say, all I want to do is when I run this script and the name of this script, I just keep it together. And when you save it with an extension of BAT like that. So on your hard drive, the name of this script would be that name. And then you start writing. For example, the first thing you want to do, let's say when you run it, you say the first thing I want to do is I want to make sure that I'm on the C drive. So you put in there C colon, just like you were typing it in the command prompt. The second thing let's say you wanted to do is I want to go to a certain directory. You can say CD backslash one second here, class, backslash and you say, and I want to go to directory A plus. That's the name of the directory. And then once you're in that directory, you want to say, I want to see what's inside that directory. You should dir to get a directory. And then let's say you needed to delete certain files that were in that directory. And let's say that this was a daily task you had to do every day. You say, I don't want to do this every day. You know, it takes me 20 minutes to get this done. I'm gonna create a batch file to do it for me automatically. And then all I have to do is just run a plus example, and it will do this for me. And then let's say once it does the directory, then you can say CLS to clear your screen. Of course, remember, you have to know the commands, right? Like I said, you have to know. If you don't know these commands, you won't be able to write the script. But these are DOS commands. And then you say, okay, I clear the screen. Now I'm going to do del, that stands for delete, but let me spell it out. Delete a file 1.txt. And then you had delete file 2.txt. Let's say that these files that got created every night, and there were a lot of them. You say, man, it takes me a long time. And I'm just gonna let's say there were 50 of these files, and you can say delete file, and let's just say I put all my 50 entry file 50.txt, and then you know, I'm skipping steps that would go in here, right? All these other deletes, but that would be 50 delete commands you don't have to type in. And then once you do the deletes, you say, okay, after that, I want to do another directory to see if those files are gone. And then you could do a dir. And then it says, and once and better still, let's say here that you went to the D drive. Okay, there, all this is on the D drive. And again, better still here is D drive. So you do all these things. Then you do a directory again here, and then once you do the directory, say, okay, let me clear the screen again. And now I want to go back to the C drive, so I do I want to go back to my regular just D directory, so I can do a CD, change the directory back to just the regular CD here instead of the A plus. I go back, And once I do that, I want to go to the C drive. So I type in C colon. And this is something you have to do every day. So you put in all those commands, and then once you do that, you save this script. And let me file, let's say save as, and then I would just save it here, and I just say, I'm just going to say sample BAT file script. And that's it. And once you do that, you saved it. And every morning you could just said, I need to get rid of these files that get created at night. They're temporary files that are not needed the next day. Just run in a plus example.bat, and it runs the commands that are inside here. Okay, class, that gives you a really good example of what a script is. Okay, so and as I said, you choose whatever script you know how to write. Here you say, well, the only ones I know how to write is the BAT, as I just gave you that example, because it's very simple, because it's just a matter of just typing in the commands. But if you say, I also know PowerShell, I'm going to do what you do in PowerShell. I know VB script. I'm going to use it using the VB script. So those are the scripts. There's other languages, JavaScript, Python. If you know those, then you can use those. And again, they're complex. Again, you can see. Just to give you an idea, see, you can see here. Look at it. You would have, and you can even print some things out to the printer and do other things, or print to the screen. But bottom line is, you have to know, especially, let's say you were doing Python scripting. I guarantee you, you're gonna have to take some time to learn it, whether you take a class or you do self-study, and to learn Python. JavaScript is another language, but again, the objective here for you to know is that you have script. So you look at the batch, but you say, well, I need to do one that's more elaborate. I can't do it with the BAT. Let's get one of the developers that work for the company to write this one that does a lot more things. But again, these are two other scripting languages that are available to automate processes. A use case for scripting. So again, interacting with operating system, native commands. For instance, native commands would be, you saw me do the BAT file just now earlier. And that would be those commands I'm putting in there are native commands, because those are commands that are run in Windows. Windows recommends that. Those commands I put in that BAT file are commands that Windows understands. I wouldn't put those commands if I was doing it in Linux, because Linux has different commands. I wouldn't have to know the commands for Linux, of course. And then OS application programming interface API and scripting libraries. Again, it's just a matter of knowing the script. In use cases for basic automation, restarting machines. You saw me do a basic one, the BAT that did changing directory, changing drive from the C to the D drive, and deleting files, right? Clearing the screen. CLS was a command. So restarting machines may be one reason you do that. Remapping network drives, right? If you want to remap. Installation of applications. You could also have it to install applications. Initiating updates, automated backups. You could do that. Gathering of information and data. So whatever it is that you have to do, and you have to automate the process, you can do it with a script. And this, again, the reason for the script is to save you from having to do the process manually, getting to the areas where you need to get into within the computer, using the keyboard to put the commands and doing all these other things. In this case, we see the example one more time. If test path happens to be the L drive, get a PS drive and remove a PS drive. So they could be doing here's maybe some mapping or something, and unmapping. And then a new PS drive, L persist PS provider. So they're changing the drive to a different drive, pointing to a different drive. File system root, that subdirectory is MS10, and then the name of the folder is lab files. Okay, so maybe you had to point from one drive to point to a different drive, and in that drive you have to go to a directory where the lab files are located. And let's say that every time a student needed to get to their lab files, all they have to type in is one command, and their position wherever the lab files are located. Or when the student logs in at login time, you can automate it to run the script, and the student's automatically in the lab files. So different reasons why you want to run a script. But the thing is that scripts are very useful, and but the bottom line is you have to know how to write the code to write the program, because the script is a little program. So the best practices, as we can see here, is unauthorized modification of source code. So these could be some malware risks that somebody could write a script and somehow get it into your system where you're not aware, and it's a hacker, and then the hacker plants the script and launches it, and it could have 100 things that it does, but the hacker's not doing it themselves. They already wrote the script. They just launched it, and it's running 100 commands. Whatever those commands happen to be, they're deleting files or they're doing other things. Unauthorized modification of source code, increasing attack surface and exposing vulnerabilities. So inadvertently changing system settings. So just make sure that when you write the script, it is correct. If you make a mistake on the script, that it could be the incorrect thing to do. So when you run the script, it's going to do the incorrect thing on your system. Lockout due to changing firewall configuration. These are some of the things that the hackers could do as well. They could lock you out by going into the firewall with the script and closing out certain ports. And then all of a sudden, home users cannot connect, for example. Disabling security features to get script to run. And then browser or system crashes due to mishandling of resources. So again, the temporary log file creation, endless loops. They can put you into an endless loop. You know, we said in your script, you have a loop that if certain condition, do something. If not, go back and add one to the counter, and you want to do this so many times, it can go into this loop until the condition is met. And let's say that your condition has an error in it, and the condition is never met. Let's say it's never met. It could go into this loop forever, and it stays there forever. In essence, it's like the program gets locked up, or your machine gets locked up, because it never exits the program. So those are things to be careful with. And some of these hackers could run a script to put your system in a loop on this script, and it's taking up a lot of resources, and everything becomes so slow because this script is running, nonstop. And then a faulty use of APIs. So APIs are supporting many modules that support the regular scripting language, the APIs. They're just additional commands that can be inserted into the main script. Anyway, so just understand the concept of the scripts, and know that you have to know the syntax and know how to run this, how to be in essence a programmer to run the scripts. So anyway, class, what did we look at here in this topic? Shell scripts, basic script constructs, right? The syntax of it. Windows scripts, right? Whatever shell you're going to use, you have to know the rules of that shell. You have JavaScript, you have Pythons, right? So if I have to write something for Python, I have to know the syntax for Python. And whatever I write for Python, those commands in Python, I cannot transfer those commands to JavaScript. JavaScript has their own syntax, their own way of describing things. Even if I have to do the identical thing, I have to use the right language for JavaScript and use cases for scripting. So, right, when do you want to use the scripting? Why do you want to write a script, right? So, and then scripting best practices and considerations as well. So, a really good topic on scripting, because you may be not necessarily writing the scripts at the beginning of your careers, but eventually you may. But by then you will learn, the constructs of the script that you're going to be working with. But in the meantime, you may be running scripts. Understand what they do. What's the reason for them? So anyway, class, this brings us to the end of this lesson. And at this point, then, we are going to break for lab as we normally do. And of course, if you have any questions, I will answer them for you. Continue interacting with me via email. And we will again meet online on Wednesday. And we'll go from there. So at this point, then we are going to break for lab. This less, lesson, really has some really good things that more than likely you will be exposed to in your careers. So having said that, class, let's go ahead and break for lab at this point in time. I will stop sharing and I will mute myself. And thank you for your attendance.